Well, hello guys, how are you? I am here to go over the review I sent you for 6.5 to 6.7. The test on this will be posted on Thursday morning, and you'll have until Monday night to get it done. And I think we're doing it at a very good pace. We're actually one day behind the calendar that I had set up, and that's not bad whatsoever. I will be posting a new lesson on Friday for the new chapter, but you have time to get that done until Tuesday of the following week. So even though the assignments do overlap, I'm not going to make any due dates the same. So you'll get the test Thursday, it's due on Monday. You get the new lesson on Friday, it's due on Tuesday. So you can work your way around that however you want to feel. Just keep yourself organized and keep us moving along. So I thought I would just go over this little review. If you know how to do this stuff, you'll be all good for our test. So we are simplifying this expression. Now, it's a cube root. So when it's a cube root, we have to take out things in triples. So 625. What is 625 when you break it down? It's actually 25 times 25. And each of the 25 breaks down into 5 times 5. So how many 5s do you have? Well, you've got 4 of them. And you also have 5 x's. So remember, they're coming out in groups of 3. So if you have 4, you have 5 to the 4th power. So you have 4 5s when you multiply them together. How many come out? Well, 3 goes into 4 one time. But that leaves 1. Remember, 4 divided by 3 is 1, with 1 left over. The x is 5. We take out 3 of them. Well, I can take out one set of 3, because 5 divided by 3 is 1. But the remainder is 2. It leaves me with 2 on the inside. So we don't bother writing things to the first power. It's just 5x cube root of 5x squared. So which one is that? Is that C? That's our answer. Okay. Number 2, we have to break down all of these roots specifically. So the square root of 5 cannot be broken down. Now what about 20? Well, 20 is 4 times 5. Now I'm going to stop right there, because what do you know about 4? It's what I hope you know about 4. 4 is a perfect square. All right, 27. 3 times 9. I'm going to stop right there, because what do you know about 9? I'm going to put that first. 9 is a perfect square. Now what about 147? Can that be broken up? I have a feeling that the 3 is going to give us a clue. Can we provide this by 3? 7, 8, 9, 10, 11, 12. If I add these up, I get 12. And you can divide 12 by 3, so you can divide this by 3. Let's see, 3 goes into 14 4 times. And that would mean, okay, do some math here. 4 times 2, so 27. 3 goes into 27 9 times. Hey, look at that. I stopped there because we know about 49. Alright, so the square root of 5 stays the way it is. What's the square root of 4? 2. Square root of 5 stays where it is. Square root of 9 is 3. The other 3 stays under the radical. Square root of 49 is 7. That 3 stays under the radical. I combine my like terms. I have 1 root of 5 plus 2 roots of 5, so I have 3 roots of 5. And roots of 3, negative 3 plus 7, so that's plus 4 roots of 3. Let's see if we've got that up there. 3 roots of 5 and 4 roots of 3. There it is right there. It's B. Sorry if I accidentally cut off D over here. Sorry. Let me, well, that's just my fault. It's a good thing it wasn't the answer, huh? Alrighty. Number 3, simplifying. Now this is a crazy type of problem. It's like, who in the right mind does stuff like this? Well, math people aren't in our right mind. Or are we and nobody else is? Think about it, but not too hard. How do I eliminate a radical written in this form? Well, you don't need to know this is called a conjugate, but this is what we do, because these will eliminate radicals in the denominator. Now I have to multiply the top and bottom by the same thing, because this is a fancy way of writing the number 1. So think about the bottom, because what we're doing is really foiling these together. Alright, so we'll do it separately. So 4 times 4 is 16. 4 times the negative square root of 2 is negative 4 roots of 2. Now we do these. Square root of 2 times 4 is 4 roots of 2. And square root of 2 times square root of 2, remember, square root of 2 times square root of 2 is 2. Or if you think about it, 2 times 2 is 4. So you can think about it this way as well. It's the square root of 4. And it's a negative because you're adding and subtracting a plus and a minus. Now the top, just multiply the 6 through. 6 times 4 is 24. 6 times square root of 2 is 6 square roots of 2. Now look what happens to the bottom. These become 0. So they're gone. 16 minus the square root of 4. Well, the square root of 4 really is 2. So 16 minus 2 is 14. Now, you're going to notice that answer is not up here, because there's one thing we can do to simplify it. The 24, the 6, and the 14, what can we divide them all by? Yes, you guessed it, 2. Half of 24 is 12. Half of 6 is 3. Half of 14 is 7. And there we are. What should be, oh, there it is, D. Okay. That's how you rationalize a denominator with that crazy thing in there. All right, radical exponents. This one's pretty straightforward. It's basically just a definition. The power is the numerator. The root is the denominator. You'll notice that 4/6 is not up there because that's a fraction that can be simplified. Divide them both by 2. You get y to the 2/3, which is right there. Isn't every now and then like an easy problem just getting zung in there? You think, wait a minute, it can't be that easy. Sometimes it is. Same with this. This isn't a difficult problem, except you got fractions. So when you divide, what do you do to exponents? Well, you subtract them. So m to the 2/3 over m to the 1/5. Well, that equals m to the something. That something is whatever 2/3 minus 1/5 is. Now, you got a calculator, you can throw it in there, I guess. I'm not going to know, am I? But if you don't have a calculator, then how do you subtract fractions? Common denominators. Agree that 15 is a common denominator of 3 and 5. Both 3 and 5 go into 15. All right, 3 goes into 15 5 times. 5 times 2 is 10. 5 goes into 15 3 times. 3 times 1 is 3. 10 minus 3 is 7. So 7/15 better be one of those answers, and sure enough, it's A. All right? Just subtraction with a little bit of, fun elementary math thrown in or subtracting fractions. All right, now we have equations. Just like any equation, I'm going to add 2 to both sides first. And that's 3. And then what's the inverse of 1/4 of a power? You take it to the 4th, because 4 times 1/4 is 1. 3 to the 4th. It's 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. Now it's a simple little two-stepper. 2m equals 80, which means you divide both sides by 2, m equals 40. There you go. Okay. Now we've got a inequality. Okay, remember the two parts of the inequality. This, under the radical, must be, whoops, yeah, sorry, 2x plus 4 must be greater than or equal to 0. Has to be. You can't have a negative under there. Alright, so let's subtract 4 from both sides. Divide by 2. So I know x has to be greater than negative 2. What's my second condition? Well, I'll just solve the whole thing and see what I get. Okay, I'm going to subtract 1 from both sides. So you get 4. Okay. Square both sides. Alright, should show the work there. Square them and square them, because a square and a square root are opposites. Now just solve it like normal. Subtract 4. 2x greater than or equal to 16 minus 4 is 12. Divide by 2. Okay, now think about this logically. X has to be bigger than negative 2. Let's look at that number line. So x has to be bigger than negative 2, going that way. But x also has to be, oh, I see. It's a greater than symbol. X also has to be greater than 6. So it's also going that way. So remember, these are only true when they overlap. Let me put this one in red so we can see it easier. So where do they overlap? Well, they only overlap when x is bigger than 6. So in this case, it's D. Alright, so let's get a little crazier ones with the inequalities. But remember, inequalities are solved kind of like normal equations. You just got to test points. So you'll notice if you pick any number bigger than 6, this is going to be correct. Any number less than 6, it's not going to be correct. Any number less than negative 2, it's super not correct because you can't even do that. Okay. The formula. So you see problems like this, it's always just going to be a formula. You just got to plug numbers in. Let's see what we got to plug in. Velocity of an object, mass of 11 kilograms. Alright, that means that we know this is 11. Kinetic energy is 550 joules. So 2 times 550. Well, now we're just going to plug that thing and figure it out. So 2 times 550 divided by 11. Let's see what my calculator says. 2 times 550 divided by 11. Oh, it's 100. Wow, what do you know about that? So what's the square root of 100? It is 10. We have 10 meters per second. Oh, it's 3 D's in a row. D, D, D. Happens sometimes. And it was kind of random. I just picked these answers from problems in the book. Didn't even look at them. They're all D's. What do you know? All right, plugging in formulas. How many we got? We got 2 more multiple choices. Okay. So, what do we have here? X, the 5th root of x cubed really means x to the, remember the power and the root. Well, think about this. These two are exactly the same. What's anything divided by itself? It's just 1. Or if you think about it this way, 3/5 minus 3/5 is 0. And remember, anything to the 0 power is 1. Okay? Keep that in mind. All right. Number 10. Oh, another formula. What are we given here? 6 seconds, so we're given time. We're given this now. Okay, well, it's a root. So what's the opposite of a square root? A square. 36 equals d over 16. Put that over here. So how do we solve for d? Multiply by 16. 16 times 36. It's 576. The answer is C, 576. I think I made a mistake on your answer key. I put H instead. And you say, why did I put an H there? Well, it was one of those where it was A, B, C, D, and then E, F, or was it G? Well, anyway, it was H. Anyways, it's C. It's 576. Okay. So I apologize for that, but it's C. All right, not a multiple choice, just flat out figuring these out. Well, what's the square root of 9? 3. What's the square root of 25? 5. There's the answer. Let's go on. Fourth root, we got to take out 4s. The x's and y's are okay. The 32 we got to figure out. Okay. We have 5 of them. 11 of these. 8 of these. Here we go. 4 goes into 5 one time. Leaves 1 in there. 4 goes into 11 2 times. 4 times 2 is 8. That leaves us 3 extras. And 8 goes into 4 twice, and it goes in as a whole number evenly. So 8 divided by 4 is 2 with no remainder. So there it is. Let's make it a little bit nicer. We don't bother with writing things to the first power. Put a little dot there to separate these. So that would be your answer. Okay. 2x squared y squared times the fourth root of 2x cubed. Oh, another one we have to simplify, so we got to put these together. So 50 is 25 times 2. Or I like 25 because I can find the square root of 25. 45, 9 times 5, 18, 9 times 2. So I broke them up into perfect squares. All right, what's the square root of 25? It's a 5, so a 5 comes out. Square root of 9 is 3. 5 stays in, square root of 9 is 3. 2 stays in. What's 2 times 5? Is 10. Almost done. What is the last thing that we can do? Well, we got 2 terms with a root of 2. So what's 10 root of 2 minus 3 root of 2? Well, it's 7 roots of 2 and 3 roots of 5. And that would be your answer. And it is, as I confirmed over there on my answer key. Oh, another formula. D equals the square root. Square roots aren't so bad. BA. What's this BA? This BA is the basal area. I don't know why I just say base area, but I guess basal area means something different with a tree. I don't know. Again, a lot of times I don't understand the formulas. I just know how to use them. Some formulas I do know. But how many formulas there are in the world? Oof, we couldn't possibly figure them all out. Well, maybe you could, but it would take a long time. All right, what do we have? The area of the tree is 8.9 square feet. So this is going to be 576 times 8.9. They suggested we use 3.14 for pi, so let's just do it that way. So it's just a calculation. We throw all this in the calculator. 576 times 8.9 divided by 3.14. Take the square root, and you should get this. Now, I didn't actually calculate that just now, or do it in my head. I did it before, and I know that's the answer because I'm looking over here at my answers. All right, almost done. Rational exponent. So we don't want any roots. We don't want any of these. None of those. We want like fractional exponents. So let's look at the 125 first. So 125, you may happen to recognize that is 25 times 5, which is 5 times 5. So it's 5 to the third power. That's good because we have a cube root. Okay, so let's write them as rational exponents. Let's think of it this way. So the negative's okay because the cube root of a negative is still a negative. Remember that 3 is the power, that 3 is the root. This 2 is the power, this 3 is the root. However, what's 3 over 3? Well, it's just 1. So that is how you write it with rational exponents. Negative 5 times x to the 2/3. Okay, that's a little sloppy. Sorry guys, let's do it out here so I have more room to write. That looks better. But that's your answer. Negative 5x to the 2/3. Alright, this one looks a little funky, but you know what to do. First of all, let's do the bottom. When you multiply together, what do you do with exponents? Well, you add them. What's 1 plus a half? Now there's a 1.5. Okay, sure, it could be 1.5. But we're dealing with fractions here. So 1.5 is 3 over 2. Because remember, this would be 2 over 2 plus 1 over 2. That's how you get 3 over 2. All right, now I'm dividing, which means it's x to something, but that something is whatever 8/5 minus 3/2 is. All right, common denominator, 10. So we double it, that's 16. Common denominator is 10. 2 is 10, 5 times 3 is 15. Well, it's just a 1/10. That's the answer to that problem, x to the 1/10. Or, if you feel like it, because it's the same idea, you could put the 10th root of x. It doesn't say how to write the answer, so either of those should be acceptable. Not should be, either of those is acceptable. Okay? Solving. So what is the inverse of a 4th root? You got it. To the 4th power. And we did that before. That's 81. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Subtract 1 and divide by 10. It's very similar to the other problem we did, isn't it? But that's okay. K is 8. Lastly, the dreaded inequalities. How can a stupid little symbol like that make this problem so much more difficult? That's okay. First, we have to understand that that has to be bigger than 0. Right? Square both sides. That has to be bigger than 0. All right, subtract 6. Divide by 3. I know that t has to be bigger than -2. It has to be. Now let's do the b, or let's do the whole thing, I should say. That's a big gap there. All right, subtract 2. Opposite of a square root is a square. right, now we just solve. Subtract 6 from both sides. Divide by 3. Oh, look what I did. I stopped using the symbol. Let me put the symbol back. Now I never divide or multiply by a negative, so I'm set. The signs are okay. Whew. So t is less than or equal to 1. So if you think about it, if t has to be greater than negative 2, and t has to be less than 1, all right, it's one of these situations. We have negative 2. It has to be bigger than it, so it's going that way. Then we have 1. Now t is less than 1, so it's got to be going that way. Sorry, that's really a bad line. Let's see if I can try to do that again. That's better. Where do they overlap? But think about it logically. If t has to be bigger than negative 2 and t has to be less than negative 1, the answer is that it has to be between those two. Again, it's pretty easy to check. Just pick a number like 0. Is 0 between them? I think 0 is between negative 2 and 1, so plug in 0. So 0 plus 6. So what's 2? Is 2 plus the square root of 6 less than 5? Now the square root of 6 would be like 2 point something, right? Because square root of 4 is 2. So 2 plus 2 something is 4 point something. And 4 point something is less than the 5. So it's true. If you pick any number bigger than 1, it won't work. Any number less than negative 2, it can't work because you'd get a negative under there. So I know that the inequalities make things a little bit trickier, but you guys are on top of things, I know. So that is your review of the second part of Chapter 6. After we finish the quiz on that second part, we're not going to take a whole unit quiz. We're not going to do the whole Chapter 6, just each part at a time. We should be starting logarithms, our new chapter, after this. So thank you for, again, all the hard work that you do. And if you have any questions, come and see me Thursday. On Thursday at our session, we'll be going over the review. Any questions there is before the test. So I hope you have a great one, and I will see you later.